Hello children, the continuation of motion in a straight line. That velocity. See, velocity, we know that it is the rate of change of position of an object with time in a given direction is called its velocity. Here you have to mention that direction. So velocity, which is nothing but what? The displacement by time taken. As velocity has both magnitude and direction, so it is a vector quantity. We have to represent through the arrow mark which is present on the top, on the head. So V vector, which is equal to S vector by T. That means the velocity which is equal to displacement by time taken. So the velocity, as we said, vector quantity. The direction of velocity is the same as the direction of displacement of the body. Velocity can be either positive, 0 or maybe negative. That can be changed in the two way. That may be changing the speed of the body or by keeping the speed constant by changing only the direction. Velocity is measured in centimeter per second in the CGS system, meter per second by SI system, and kilometer per hour for the practical life, and 1 meter per second, which is equal to 18 by 5 kilometer per hour. For the conversion we can use it. So 1 by kilometer per hour we can use 5 by 18 meter per second. What is uniform velocity? As we said, for the uniform speed at the same way, but here with the direction. That means a particle or a body is said to be moving with uniform velocity if it covers equal displacements in equal intervals of time. So that this we can take it as observe small these intervals also. What is variable velocity? A particle or a body is said to be moving with variable velocity if its speed or its direction or both changes with time. What is average velocity? Average velocity, which is nothing but suppose a body moves with variable velocity. The average velocity of the body is the ratio of the total displacement which is covered by it to the total time taken. That is nothing but they call it as net displacement, or we can write total displacement by total time taken. Okay, so a V vector average, which is equal to S vector total by T total. Now for a body moving with uniform acceleration, we can say V average, which is equal to U vector plus V vector by 2. That means initial position plus final position by 2. The displacement you have to take it. Average velocity is also defined as the change in the position or displacement. That means del x divided by the time intervals of del t, which is the displacement occurs. That means V average, which is equal to x2 minus x1 by t2 minus t1, that is equal to del x by del t, right? Now, if a particle undergoes a displacement S1 along straight line in time t1 and a displacement S2 in time t2 in the same direction, then what is the V average? S1 plus S2 by T1 plus T2. This and all we can use it for the numerical purpose also. The case 2, if a particle undergoes a displacement S1 along a straight line with velocity V1 and a displacement S2 with velocity V2 in the same direction, then V average, which is equal to, you have to take it as S1 plus S2 into V1 V2 by S1 V2 plus S2 V1. Understand? If a particle travels first half of the displacement along straight line with velocity V1, next half the displacement with velocity V2 in the same direction. Now how can we take the average? 2 V1 V2 by V1 plus V2, right? Now if a particle travels for a time t1 with velocity v1 and for a time t2 with velocity v2, same direction, v average which is equal to, you have to take v1 t1 plus v2 t2 by t1 plus t2. If a particle travels first half of the time with velocity v1 and the next half of the time with velocity v2, then v average which is equal to v1 plus v2 by 2. Understand? Now, what is average velocity? Through the diagrammatical, the graphical represent we can see now. That is, see, a curved graph has a multiple that it contains the slopes. See, now the displacement time graph bends upward with the passage of time. The value of theta, which means it is increases. The slope tan theta of the curve increases. So consequently we have to take the velocity which is increases and the motion is accelerated motion. Now the slope p1 p2 that gives the average velocity between the 2 points, right? What is uniform velocity? We can see through the position time graph. The first one is, this will give the stationary object. The next graph will shows as the object which is at positive velocity, right? It covers equal distance with a equal time period. That is the displacement of equal time period. Next position time graph which shows as, so this graph indicates that is object which is negative velocity. See, the velocity which is decreases uniformly with time, and after some time it may be becomes 0. It starts with an initial velocity u and going down decreasing, right? So we can call it as a negative velocity, right? Now the next one is, you are going to learn about the differences between the speed and the velocity. So what is the speed and velocity? We can see the differences. Speed is the time rate of change of distance of the body. Velocity is the rate of change of displacement of the body. Speed tells us nothing about the direction of motion, only magnitude. The velocity shows and tells us the direction of the motion. Speed is a scalar quantity as we know, and velocity is the vector quantity. Speed of the body can be positive or 0. Velocity added to that, it will be also negative, positive, 0 and negative. Average speed of a moving body can never be 0. Average velocity of a moving body can be 0. Now what is instantaneous velocity? So the instantaneous velocity, the velocity of an object at a particular instant of time or a particular point of its path is called its instantaneous velocity, we can say. Or we can say, when a body is moving with variable velocity, the velocity of the body at any instant, which is called the instantaneous velocity. The velocity at an instant is defined as the limit of the average velocity. As the time intervals del t becomes infinitely, that is small, right? Now v vector which is equal to limit del t which is turns to 0, del x vector by del t, or we can say v vector which is equal to d by dt of x or dx vector by dt, right? See the graph, the position time graph, it is increasing, that is the motion is accelerated as we said. Suppose we want to calculate the instantaneous velocity at point P at any instant. So somewhere we call it as at P. Now we have to take P1 at T1 and P2 at T2, right? The 2 points we have to take it. The slope of P1, P2 at T1 and T2 with intervals of del t from t, that is t1 which is equal to t minus del t and t2 which is equal to t plus del t. We have taken the 2 points like that. It gives the average velocity at point P where we want to calculate the instantaneous velocity. Now the 2 points which we have taken, the slope of P3 and P4 at T4 and T3 and T4 at the intervals of del t by 2 from, that means T3 which is equal to t minus del t by 2 and T4 which is equal to t plus del t by 2, which gives the average velocity at P, which is closer value to the instantaneous velocity. See the points which we choose, that is very important. See, proceeding this way, the del t that may be gradually reduced to approach 0, like that way the points which we have chosen, that is del t turns to 0 to get the actual value of the instantaneous velocity. See, though average speed over a finite interval of time is greater than or equal to the magnitude of the average velocity, instantaneous speed at an instant is equal to the magnitude of the instantaneous velocity actually, right people? See, that means what is the formula for the average speed? Total path length by time intervals. Yes, average velocity displacement by time intervals. When an object moves along a straight line and in the same direction, its total path length is equal to the magnitude of the displacement. So consequently we understand that its average speed is equal to the magnitude of its average velocity. Understand that? Yes. Thank you students.